This is a resistance. So here is the slab which I'm going to put into the capacitor. R, 2R. What was initially any charge will be there in that capacitor, as there'll be some charge. Why it should have charge? It's connected to cell, no? And there's a dielectric slab. Keep it like this. So can we calculate that initial charge? Initially, where the current will flow only through this branch, no? There won't be any current through the other band. There won't be there won't be current through this resistor 2R. Only the current will flow here because the capacitor is open circuit, steady state. At steady state, we are discussing this one. So then what is the expression for I? I is equal to E by 2R. So right loop equation, calculate the potential drop. The drop across the capacitor should be the drop across this resistor. Or right loop equation plus Q naught by C minus 0 into 2R minus I into R equal to 0. Where I'm writing loop equation here in this for plus Q naught by C minus 0 into 2R minus IR equal to 0. So what is I? I is equal, IR will be E by 2. So Q naught equal to how much? CE by 2. Keep this value. Next, I am going to fill up. The moment I fill up, what will any changes one has to notice, or nothing will happen? Capacitor is steady state. So at steady state, because at steady state only I'm filling up. So there nothing will happen. Suddenly it is filled up, not gradually. Now what you can expect about capacitance? When you fill up a capacitor with a dielectric slab of K, if it fully filled up, then the capacitance will increase by K times, no? So therefore the capacitance here will become 2C. You have to be extra alert here. What do you mean by that sudden? Sudden, I'll underline in the question. Suddenly. What parameters of capacitor will change? So definitely the capacitance we know. Capacitance will increase by 2 times. Then, what will happen to the charge? What will happen to charge? Sudden, no? Suddenly charge cannot, suddenly don't make it, don't write Q or some other thing. Suddenly if charge changes means what does it mean? Law of conservation of energy is violated. From where that charge has come? So therefore the charge will remain as it is. The charge will remain as it is. Due to sudden fill up of the capacitor by dielectric slab, charge will remain as it is. At that instant only, the moment you fill up, the charge will be Q naught only, that one. So look at the potential drop now. Is there any potential drop? Earlier it was steady state, no? So look at earlier, what was the potential? Potential was equal to how much? How much potential across the capacitor was? E by 2. Is it okay? What was earlier drop across capacitor? E by 2. Now what will be the drop across capacitor now? Will it be E by 2? And I'll write it here. So what was the drop here? V naught. So what is V naught? V naught equal to Q naught by C. So they should be E by 2. Now what will be the new drop? What will be the new drop? The new drop Q naught by 2C, no? By 2C, capacitance change. So Q naught is equal to how much? CE by 2. So E by 4. So any flow of charge will occur? Yes, it is. As long as if it is V naught, there won't be flow of charge. So V naught was E by 2. Now it has become E by 4 as there will be flow of charge. So now is asking what will be the current in all the branches. So here I'll proceed like this. So I'll once with the loop one, I'll show it. It'll be easy for you because every time we did branch, no. So let me do with one problem with the loop currents. So let's assume the polarity like this. Write down the equation, solve for it, and what to do with capacitor here. So the best way of working this problem is where all capacitor is there. So we know that what was the method? If the capacitor is having initial charge, what you should do? You should replace that with an equivalent cell for that instant only. For that instant only. So what is this? VC equal to E by 4. So I'll write only E by 4. So in place of capacitor, that cell has come. Now write down the equation. So it's a simple about a two loop problem. You know how to manage it. So where is the capacitor? The equivalent is what I'm showing with a cell. So what was our question asked? Our question was asked about just after filling the capacitor, find the current through all the branches just after filling the slab. The moment I fill up, then only I'm asking you all. So this will be polarity plus minus plus minus. So write down the equation. So this will be plus E minus I1R minus I1R. So E minus 2I1R I2R equal 0. One more loop equation on this side. E minus I1R with for the where capacitor. This is a actually capacitor. The equivalent cell is what I'm showing it. Plus E by 4 minus I2 into R minus I2R minus I1R equal to 0. So this E by 4 3I2R minus I1R equal to 0. Solving 1 and 2 we'll get expression for I1 I2. Once if I know I1 I2, then I'll get the current in all the branches. I1 I calculated, I got around 11 E by 20 R. I2 E by 10 R.
Minus will get, sir. I2 minus.
I2 negative sign. Okay, now you can see that. So this you did, shall I say, at that instant. So like a T equals 0, I should replace with the capacitor with a short circuit. Since it was having some charge, I replaced with a cell. Are able to analyze? We are not doing anything very big. The same basic idea is what I'm continuing here. The moment I fill up the slab, that you can call that instant as T equals 0. At T equals 0, what I should do? I should replace capacitor with a equivalent circuit. No charge, short circuit. If any initial charge, should be replaced with a cell. Then continue the problem. Same thing, sir. What to do with any instant of time t? How to do the same problem at any instant of time t? Okay, this is good. Like t equals 0. At any time t, I want the current. So what do you expect charge in capacitor? So you look at the potential. What are the, again, it will attain steady state, no? At steady state, what should be the drop across capacitor? Look at this one, E by 2. What is the drop here? E by 4. So what this cell will do, the cell and circuit, what the circuit will do, will again make the capacitor to attain this steady state only. So definitely what will happen to charge in the capacitor now, after filling up, we'll try to increase, no? We'll try to increase further so that it should be equal to E by 2, again the drop. So you can write at any instant of time, you write Q naught plus Q, then write loop equation, then again solve it. Okay, got this one. So so now I can fill up a slab, I can fill up a capacitor suddenly, or I'll remove the slab suddenly. So charge on a capacitor cannot change suddenly. So therefore, what charge was there, you have to retain that. This idea is very important. The Q naught, what I shown, that is the concept. If you go wrong there, I think everything will go wrong. So when suddenly capacitor is filled up by a dielectric medium or suddenly removed, charge in capacitor at that instant remains same. With the time again it will change. I think you have to understand my what I'm speaking. You should have a clarity. I'm not saying charge in capacitor will not change. Due to that event, it will not change. What is the event? Filling up or removing the slab. Then after with the time, the charge across capacitor will increase according to the circuit conditions. So I'll write down the data with the time. Charge across increases